In this section, we will discuss denial of service attacks on models. Denial of service means that an LLM is so busy processing attackers' instructions using all its computing power and resources that it becomes unavailable to process legitimate users' instructions. Denial of service vulnerabilities have been around for many decades. With LLM systems, the traditional denial of service attacks are still relevant. At the same time, LLMs have their own variants of denial of service attacks. LLMs are usually accessed through an API known as an inference API, or a mobile or a web app interface, where users send prompts and the LLM responds. LLMs also support accessing external resources and documents. So that means someone can upload an unusually large document or a web page that has a very long text. Go ahead and try uploading a very big document to one of the LLMs that you're authorized to test. Let's first start by DOS attacks on the network layer, because LLMs are connected to a user interface or another service. Denial of service attacks on the network layer can be caused by SYN floods, where attacker tries to open a TCP connection by sending SYN requests, but intentionally not completing the handshake for the final connection. The server ends up waiting for too many open handshakes and becomes unavailable to fulfill other requests. There's also a ping of death technique, where attackers sends larger, oversized ping packets, causing the target system to freeze or crash. Attackers can also try another DOS attack named Smurf attack, where a network's broadcast device starts targeting the victim's IP address to send large amounts of ping requests. Similar to SYN floods, HTTP servers can also be flooded with a high volume of HTTP requests, overwhelming the server and making it unavailable to process other users' requests. Slow Loris is another famous attack where a HTTP server is overwhelmed by sending slow partial requests. With prompting the LLMs, we will be looking at different methods of causing a model denial of service: resource exhaustion, context window exhaustion, expensive operations, complex mathematical questions. What if an attacker sends repeated prompts to an LLM to process or translate large documents? We have solutions to defend against DDoS attacks to some degree, but many translation requests that consume huge amount of computing power can go unnoticed and consume computational resources beyond their abilities. Before we look at context window exhaustion, let's understand what context window is. Context window is the maximum amount of text in terms of tokens that an LLM can process at once. Try uploading a big 100-page document to an LLM and ask it to summarize it. The amount of words in the documents, that is words as tokens, are proportional to the context window. So context window is the amount of words or tokens that the LLM can handle in order to provide a meaningful conversation. Context window includes both input prompts and the output responses that are generated. Let's look at how chatbots remember conversations. Here we have an example of invoking an OpenAI API directly, where we tell the LLM that my hobby is polo. We make another API call subsequently to the same OpenAI API with the same OpenAI key, and we ask, what's my hobby? The LLM does not remember our previous conversation. When we're directly interacting with the LLM using an API, LLMs do not maintain history of previous conversations because LLMs are stateless. On the contrary, Here's a chatbot using the same OpenAI API behind the scenes. We tell the chatbot that my hobby is polo. When asked next, the chatbot responds saying, well, based on previous conversations, you mentioned that your hobby is polo. Notice the response says, based on previous conversations, which implies that LLMs have some kind of temporary memory. But in reality, when you ask a question to a chatbot, the chatbot prefixes all your previous conversations along with your new prompt, sends it to an LLM. So the LLM has the context of all your previous conversations and your current prompt, and then it generates a response. So in case of a chatbot, the prompt, the response, and the previous conversations are all part of a context window in an LLM. LLMs use context window to temporarily remember the context of conversations. So the LLMs can predict the next correct word. And context windows are implemented as tokens. Tokens are a finite resource, just as how context window is a finite resource. If an attacker sends a large prompt or craft a prompt asking the LLM to provide an elaborate response, it could easily end up filling the LLM's context window. Attackers can also ask complex reasoning and chain of explanations. For example, consider the prompt, list and explain every step involving in the production of an autonomous robots used in manufacturing, including details from how the raw materials are extracted, cured, molded up until the final delivery of the robot, and include details of how autonomous robots' production process in each stage brings changes in the social and economic status of a country. This prompt is going to ask the LLM to link multiple domains of knowledge, and one domain of knowledge should be linked to another domain for impact. A prompt like this is going to consume more resources, and it's going to take a long time to process. Another example of complex generations could be write a detailed history of every Olympic event occurred till date. Include all the sports and identify a sport that was introduced in a certain Olympic game. Write a list of each players in an event each year. Include data from Summer Olympics, Winter Olympics, and Paralympics as well. Also include the prize money that every country took home. Can you imagine how expensive this operation could be? Would your LLM respond to this prompt? Asking questions like, what's the sum of all the prime numbers up to 1 billion? Is going to require identifying all prime numbers first and then summing them up. That's a complex mathematical question. If the 1 billion does not work, you could try with a shorter number. Like, what's the sum of all prime numbers up to 1 million? And then slowly you can iteratively increase that number to 20 million, 500 million, which would help you test the limits of your LLM. What can we do to mitigate denial of service attacks? From a network and application security perspective, you will have to introduce rate limiting per IP address or per user, and also take advantage of the network level DDoS solutions to reduce DDoS attacks. You will also have to monitor the utilization of resources to identify abnormal spikes or patterns that may indicate a denial of service attack. To defend against context window exhaustions, you will have to set limits on the tokens a user or an endpoint is allowed to consume. For example, you can set the context window to be 4096 tokens, in which case you can enforce the maximum number of input and output allowed for an LLM operation as not more than 4096 tokens.